All right, so hi everyone. My name is Augustin Popa. I am a product manager on the Microsoft C++ team. And basically I've been on the team for close to 7 years now. I've worked a lot on Visual Studio features, everything from like the productivity experience for C++ developers, the setup experience. And more recently I've been working on package management. And we have this package manager called Vcpkg that I guess I'm the product manager for that. And I'm glad to see so many people here today about this talk that is about package management. It's not specific to Vcpkg by any means. I'm going to talk about various different types of package managers. I will also talk about the underlying problems in C++ development around managing dependencies that may lead to wanting certain types of package managers. So I guess just to get, before I really get into it, if you do have any questions for me later and you don't have time during this session, feel free to go to the Visual Studio channel on the CppCon Discord, which will be around during the conference. There's also a Microsoft booth. You can find me there today and tomorrow. And as well, if you have any questions for anyone else from Microsoft or about any of our tools that we make, like Visual Studio Code, VCPkg, the MSVC compiler, GitHub, whatever questions you might have, feel free to stop by. And we also have a survey, which you can go and take at the booth if you get a chance later, and we'd appreciate it if you did. Okay, so I guess to kick things off, there's an ISO C++ survey that goes out every year. And the questions are pretty consistent, and it gets quite a few responses, well over 1,000. It's gone down a bit during COVID, but it's still been doing pretty well there. There's quite a lot of questions about basically how do you do C++? Like, what are you doing? What kinds of projects are you working on? What are the issues you're running into? And it's a good way to kind of see how the community feels about different topics. My personal favorite question is, which of these do you find frustrating about C++ development? And that's because I work on C++ tools, so my job is to figure out how do I solve those problems for you. There's a lot of different options here. Everything from build times, how to deal with specific build systems, security and type safety, moving to the latest standard, even setting up your environment from scratch, like installing your compiler and everything on your machine, working with CI. But the number one pain point, if you look at how people respond, so they can basically say it's major pain point, minor pain point, or not a significant issue. The number one has been managing libraries my application depends on. And it's actually been pretty consistent. So clearly a significant number of C++ developers are not happy with the experience for managing libraries. And I think there are a variety of reasons for this, and I can't get into all of those during this talk, but I will cover some of them. And I will allude a little bit to some of the other ones as well. So clearly this is a problem that remains unsolved, and I know my team at Microsoft is very concerned about solving this particular problem. It is, after all, number one. I should mention a close number two as well is build times, which also semi-relates to packaging as well, and I'll get into that as well. All right, so another question that follows up from this is, how do you manage your first and third-party libraries? And there's a few different options. I'm not going to talk about other and none of the above, but the other options on that are basically, the ones on the left are, I do some form of manual dependency management. So maybe you have a library, you're including the source code as part of your overall project and you're building it all together. Or maybe you're compiling it separately and then linking it into your project and making sure your build system can find the headers. Or maybe you get lucky, you can download a pre-built binary off the internet, don't have to build anything yourself. There's that option as well. And then the options on the right are some kind of package managers. So I'll talk about different types of package managers. I'm not going to get into them right now, but you have system package managers, and there's a few specific names that come up as well in the survey. So if we look at actually the breakdown for this, so this is multi-select. And it's very clear people are doing more than one thing on average because we have a lot of responses for a lot of the different options. But the two biggest ones there are the library source code is part of my build, and I compile it separately using their instructions. So it seems that a majority of C++ developers are manually managing dependencies at least some of the time. And then we have system package managers, which I guess that's not too surprising, especially if you're a Linux user, you'd expect to be using system package managers. Then download pre-built, and then we have the specific package managers at the end. Now, I should mention that the two options there, Vcpkg and Conan, have been going up year over year. I believe from 2021 to 2022, and this survey is from this year, by the way, 2022, they've gone up by about 5%, so we've reached about 19% coverage for each one. But we still have a significant number of people clearly that are not using one of these options. And there's also NuGet, which is actually not a C++ package manager. I'll talk about that one later as well, but there's a reason people also use NuGet for C++. All right, so we know that people don't like managing libraries. And we know that a lot of people are manually managing their libraries. So what are some of the issues you have to resolve when you're manually managing libraries? Well, one thing is ABI. So because C++ is a pretty low-level programming language, there are other programming languages where you don't have to worry so much about exactly how do I build each part of my project, from like the core project itself to all the dependencies, to make everything work together. Other programming languages have a much easier packaging story, I guess, that's designed from the beginning, and that because it's a higher level language and a lot of the low level details are abstracted away from the developer, you just have an easier development workflow. But with C++, you don't have that. So you have to worry about certain things when you're putting together the different pieces of your project. So let's say you have a project and you have a couple of different dependencies, some libraries that are linking to your project. So what happens if you make one of these changes? Like if you change your compiler, maybe you decide you don't like GCC and you want to use Clang or something. Or maybe you just want to upgrade the compiler version so you get the latest features, the latest C++ features, maybe performance improvements, bug fixes. Or maybe you decide, I want to go cross-platform. My Windows-only project should not be Windows-only anymore. I want it to be running on Linux and macOS as well. Or you look at different target architectures. ARM64 is seeing a surge in popularity now. Okay, you need to build your project for ARM64, now what? Now you get a completely different binary. And there are some dependencies that are complex enough that they have optional features that you can turn on or off, and that results in a completely different build as well. So the problem is you have to somehow you have to somehow build the world here, build your dependency graph in a way that you don't have an inconsistency. Because if you have an inconsistency, then your build will just fail. And you have to diagnose that and figure out what went wrong. And then you have the diamond problem. So the diamond problem of dependency management, what does that mean? Let's say you have a project. This is the simplest possible example for this, by the way. It could get a lot more complicated, but in the simplest case, you have a project. Let's say the project has two dependencies, library A and library B. Library A is version 1.1. Library B is version 2.2. But it turns out both library A and B have their own dependency, and that's library C. They both want library C. You might not want library C, or you might want a library C, but either way, you need to have library C in your build graph. But then the question is, what version of library C are you going to get? Well, if you're lucky, A and B will both want exactly the same version of library C. But if you're unlucky, they'll want a different version. And then you have a problem, because you cannot build this code if you have two different versions of library C in the same build graph. You have to somehow reconcile the different versions here, the library A, B, and C, and come up with a combination of versions that gives you a successful build. So one thing you could do is you might realize after some trial and error or some investigating these different repos, okay, if I downgrade library B to version 1.7, now it wants just version 1 of library C. And then I don't have to touch library A. I can say I want version 1 of C, and I just downgrade B. And now it actually works. But this is something, if you're doing it manually, you have to figure this out yourself. Now, package managers, or at least some package managers, at least the good C++ ones, have adapted to solve some or all of these problems. Now, they're not necessarily solving it 100%. There may be edge cases, there may be situations where you still have to do some work, but they should be able to save you time in terms of solving these issues and figuring out these ABI inconsistencies, dealing with diamond problems. this is something that it's very important for a C++ package manager in particular to deal with. And I'll give an example from Vcpkg, which is the tool I work on. So one of the interesting ways in how Vcpkg is designed, if you go to the GitHub repo for Vcpkg, you're not actually going to see the source code for the tool itself. That's in another GitHub repo that is like pulled in. But the main GitHub repo is actually the public registry, which is basically a catalog of over 1,900 open source libraries, popular C++ libraries. And everything that's in that catalog is basically tested at build time. So what happens is, let's say somebody wants to introduce an update to Boost. Well, if they try to introduce an update to Boost, what happens is, obviously Boost has to be built, which means everything that Boost depends on is built. But it also builds everything that depends on Boost. And all of those have to succeed. If they do not succeed, that PR is rejected, and the person has to try again to resolve it. So essentially, when you look at the Vcpkg catalog, it's like you have 1,900 plus libraries that each are set to a specific, and each one is set to a specific version. So not only are you addressing the ABI issues, but because all the libraries have to be built against each other, we validate that a version of library A and a version of library B actually work together. And we call this version set of all the libraries a baseline. So in Vcpkg, you don't actually have to say, give me version X of library A and version Y of library B. You can just say, give me this baseline. And a baseline is a Git commit ID, and it's just the point in the Git history of that repo. It's basically just a timeline, and you're picking the point in the timeline that you care about. And you don't have to worry about diamond problems because that's already handled. For ABI issues, you have, it's basically built against a lot of different possible build targets. So x64, x86, ARM64, Windows, macOS, Linux, combinations of all these different things, even Universal Windows Platform. They're all part of this test. So when we compile these libraries, when a change is introduced, we compile against all these different build targets. And we make sure that all the versions actually work together. Now you can still say, I want a specific version for this library, but I'm just saying that this is the default. So when you say, I want to install 12 libraries from Vcpkg, you will have some guarantees that they will actually work together without you having to manually diagnose these kinds of issues. All right, so I want to talk a little bit about the importance of keeping your dependencies up to date. So I've talked over the years to many developers that have dependencies in their projects, library dependencies, and have basically admitted, hey, I don't really like to touch my dependencies. It's been 2 years since I last looked at this. I don't want to mess with it, because if I mess with it, it's just going to break everything and I'm going to waste a lot of time. We've had people who couldn't upgrade to the new version of the MSVC build tools, which we also ship, because of their library dependencies also having to be recompiled along with their project, and they have to figure all that out. And that's actually why Vcpkg was created in the first place, because we wanted to automate how you actually can build your dependencies, so that you can upgrade your MSVC and then by upgrading all your dependencies. And in general, automating your build workflow automating the workflow for acquiring and building your dependencies is very useful if you want to keep your dependencies as close to the most recent version as possible. And a package manager can help with that. And the worst case scenario is when you have say an open source dependency and someone exploits some vulnerability and your dependency is out of date. And now suddenly there's news articles about how there's this attack happening, and now you have to update, and you have to update it as soon as possible because it affects the security of your project. So if you have a workflow that's set up to easily manage and update your dependencies, you can react to that more quickly. Okay, some other C++ package manager features that I think are very useful. So I did talk about some of them, or alluded to them. Building packages from source, I think, is very important for C++. So the alternative would be you have a catalog that's large enough with pre-built libraries that covers every possible build configuration you could possibly want, from every single compiler to every single compiler version to the different architectures, including all the ones that maybe embedded developers are targeting, which expands the list significantly. And you get the idea. This list would be prohibitively large. So rather than saying, oh, we can just build a catalog that has everything you could possibly ever want, including every customization and special build flag that you add. Instead of that, you want to have build from source, because then you can customize it. If you have something that's not like one of the common defaults, you should be able to just build those packages from source. With that said, there is value in downloading pre-built binaries, because of course building, number 2 problem for C++ in that survey was build times. If you're building all the time, that's not great. You're just shifting from one problem to the second worst problem. So you want to have a system for actually caching those binaries somewhere. Some package managers will just provide you with pre-built binaries up front, so they have like some public cache. System package managers and Conan are an example of this. But hopefully all package managers will give you a way of being able to cache the packages somewhere yourself and then be able to pull from that local cache for your own uses. So that way you only build once you figure out how you want to build everything. And then you just download the pre-built binaries from the cache and get the headers and link everything together. The other thing is, versioning, critical feature for absolutely any package manager in the world. I don't care what programming language you are or what kind of package manager you are, you need to be able to say, I want this version or this version. And with C++, I mentioned some interesting cases where you might even want to have like a broader definition of a version for like an entire group of packages, so you can upgrade them all at once and make sure that that upgrade is smooth. And that's like what we do with the baselines. Another thing this is an issue that I've heard about a lot in the past couple of years, is setting up a reproducible build environment. And there's actually a CppCon talk about this, which I'm curious to see how that one goes. I certainly recommend checking that out. One problem that I've heard developers talking about is how should I set up my machine to install the compiler and debugger and the tools that you're giving me? Like, how do I actually set them up? And we don't have necessarily a good universal story for that. Now, if you're using system package managers, that's a story if you're on that particular system. But in general, this is an area that I'm starting to see package managers paying more attention to, including like the C++ ones. But the general idea here is you should have some kind of a manifest where you declare everything that you need. And the idea is if somebody else clones your project, which also has the manifest, the package manager should be able to just read the manifest and produce exactly the same packages, exactly the same, every time. Whether you're doing it from your local dev machine to CI, whether a new team member joins your team, it should be consistent. And it's important to have, as well, a very expansive catalog of packages, covering all the possible cases you might care about for C++. Like I mentioned, for open source libraries, there are thousands of them. So you want to have as many of them as possible available publicly for people to use. And there should be some testing. You don't want your users downloading packages that are broken. That would not be good. So there needs to be some validation when someone tries to add something to the catalog that it's actually going to work for people. And you want a consistent experience as well, whether you're getting open source packages or you're getting closed source ones. So basically, like, a company should be able to produce their own packages for their own internal use, and their developers can use the same workflow to get this open source dependencies as well as the closed source ones. And relating to that is being able to download packages offline somewhere. So there needs to be a way to put the catalog offline and disconnect it from the open internet, which is important for security reasons for a lot of organizations. If you're like working on a small school project or like some open source project or something, maybe that might not be too important for you. But if you're like an enterprise that's really concerned about nobody hijacking your build process, which is an issue that has been coming up recently, unfortunately, in the news, it's good to have that separation. And the other thing I just want to point out, open source package managers are great because they have so many contributors. And while some companies have their own in-house solutions for managing dependencies, chances are an open source project is going to grow at a much faster rate just because it has so many more contributors. And that's something that you can take advantage of. It's like free engineering time. Okay, so I have a maybe kind of obvious hypothesis that developers are more likely to adopt a new process or workflow if they are more productive with it after they adopt it. So I think this makes sense. There is some effort involved in changing the way your build process works and changing the way you're acquiring your dependencies and managing them. There is an upfront cost associated with that. It's not free. However, if you pick a good solution for that, like a good package manager, and you have a good build system, and your build environment is generally set up correctly, you should be able to save time in the long run. Your maintenance time should go down, which means this should be a worthwhile investment. And that's what I think today we're at a state where C++ package managers absolutely can give you that. There's still more they could do. They're not perfect, but this should be an improvement over doing things manually. And here are some reasons when you might want to think about when should I use a package manager. If you have more than 1 or 2 dependencies in your project, because each dependency, if you're doing it completely manually, you have to figure out how to build it. You have to build it correctly and link it into your project. A package manager automates that. So the more dependencies you have, the more case you have for using a package manager. And then you might have dependencies of dependencies, which is also a complex thing you have to worry about because that's when diamond problems start to come in. You have to figure all that out. That might be a good case for a package manager. Open source dependencies. Package managers are very good at handling open source dependencies. They're very well understood. So might as well save time and take advantage of that. If your project doesn't have dependencies, but you want to implement you want to add some new code that does something that someone's already done and published as a library online, it's probably better to take advantage of that and not have to do the work yourself and then have to maintain that code yourself. Another reason is if you're thinking about making your libraries header only just because it'll make them more portable, like, oh, it's easier to pound include a header than to figure out how to build this thing and link it into my project, that's not a good argument for using header only libraries. There may be other arguments like something to do with templates, but that reason alone should not be it. If you have a good package manager set up, it's okay to compile your libraries and link them into your project, and it should still be pretty automatable. And in general, maintenance time and security, if these are really big concerns for you, package managers may be able to help. Okay, I do want to talk about, I have one slide on modules, but I'm not going to spend too much time talking about modules because sometimes I get the question of, well, aren't modules supposed to fix the way we deal with headers and libraries and all that? And in general, there are some issues that modules will address, but they're not really the issues I just talked about so far. The issues, so modules will probably, at least I hope, will bring down the number of respondents saying that managing libraries is a problem. There are other issues that come up, like being able to encapsulate macros and using declaration, dealing with some ODR violations, even cleaning up your file system a bit and not having copies, like basically you have a source file and a header file, source file, header file every time. And the overuse of headers during pre-processing. Although some tools will offer something called a pre-compiled header to deal with that, but people tend to either not use it or not use it correctly. So modules will definitely help with all of those things. But they won't really fix the fundamental issues with C++ and how C++ compilation works. And you're going to have the ABI issues. You're going to have the diamond problems. And the other sad fact, I think, is that it's probably going to take a very long time for everyone to switch to modules. That's just the reality. We still have, the tool vendors are still working on finishing up implementation for supporting modules. And then it will take even longer when we think about there are thousands of open source C++ libraries that would need to be ported, not to mention all the closed source projects that are out there, which are probably maintained by a smaller group of people. It's going to take a long time. So in the meantime, though, there are things you can do to improve your dependency management experience, and that's the package managers that are on the market today. So the goal of this talk is not to go through every single package manager and tell you which one to use specifically, because I do not have enough time to do that. There are so many options. And these are just a couple of options, frankly, in a sea of much more options. So I will give you some categories of package managers. And I'll talk a little bit about when you should use each one. So I mentioned system package managers before. And some examples are like apt, pacman, yum, rpm, Ubuntu package manager. There's lots of them. They're very popular on Linux especially. And I guess on Mac OS, on Windows even has NuGet now. So this is definitely becoming a common pattern no matter what operating system you're on. Then you have what I classify as C++ package managers. So they're package managers specialized for C++ development. The two big ones in the survey are Vcpkg and Conan. And they've been growing quite a bit year over year. There are lots of other options though. It's just that they're not showing up a lot in the survey, so I haven't listed them here. But if you go looking online, you will find, I think every couple of months I see a thread on Reddit about somebody creating a package manager for C++. Everyone tries to solve these problems in a slightly different way. And then you have other language package managers that are not for C++. And this might seem like a weird one to include at CppCon, but I'll talk about why I am including that in this list shortly. So let's start with system package managers. So system package managers are designed for a particular operating system distribution, really. If you're constraining yourself to just that system, if you're writing code for that system, you're only targeting that system, then you might not have a big reason to go out to a different package manager because you're already using a system package manager to install everything you want for that system. You're installing all your applications, you're installing different libraries, or you might be working with different programming languages, and you can still find packages in the catalogs for your system package manager. If you do go cross-platform, it gets a bit more complicated because then you have to have some kind of build conditions for, okay, if I'm actually on this system, then I can use the system package manager, but if I'm not, I'm gonna have to do something else. And packages are installed usually system-wide, and often you require some level of elevation. So if on Windows, that's like your administrator account login, sudo on Linux. And this can be good if you want to have something that's available for all your projects to use and you're not copying packages multiple times in multiple places. It can also be good as another layer of security. Like, in order for this package to be downloaded, you need to authenticate that you're actually who we think you are. But that can also be a downside because maybe you actually want two versions of the same package depending on which project you're in. Like in one project you want this version, in another project you want a different version. It's also the case that many system package managers will not support build from source. They kind of just give you a pre-built. Everything, like they'll give you binaries and sources and whatever. You can put anything you want in the package. But they don't necessarily do a lot of work to actually prepare that package for your machine, for your particular environment. There are exceptions though. There are system package managers that do build from source like pacman. But that's just something to watch out for. Remember I mentioned I think build from source is very important for C++ development. They're not exclusive to C++, so again, like if you're doing stuff across, if you're using that system all the time, there are reasons you might just want to stick to one package manager so you have one workflow. And then the build system integration is also a bit interesting, where system package managers are not necessarily focused on software development. They have more broad applications. So it's not like they're not necessarily going to hold the hand of your build system and say, okay, here, let me help you as much as possible. But what they can do is they tend to install things to a very well-known location. So a build system should hopefully be able to say, oh, okay, I see you're on this Linux variant, and your packages are probably going to be installed to this libs folder, and I'll go and get them from there. So that can still work out for you, basically. And yeah, they're most popular on Linux, but they are seeing, even on Windows, which you'd think would be like the anti-system package manager OS, actually as, I mean, it's had chocolatey for a while, but there's actually like a Microsoft one now, which is NuGet as well. Okay, so then C++ package managers. So the two big ones in the survey are Vcpkg and Conan. They've been neck and neck for the past couple of years. And they do have some differences in the way they work. But in general, if we look at like what do C++ package managers have in common? So they do have some more advanced features. So things like dealing with diamond dependency problems, building packages from source, having some validation when you're downloading something that's pre-built so you're not wasting your time. having a large catalog of possible C++ packages, that's absolutely a huge one. You won't find a bigger catalog of C++ packages than if you look at a C++ package manager. In particular, if you're looking at Vcpkg and Conan. And of course, they have workflows for private packages as well. You can prepare your own private packages and publish them somewhere. Or you can prepare an open source one and publish that one as well. And another scenario that we have some support for, but maybe it's not like 5 stars out of 5, is acquisition of other stuff, non-libraries, like build tools, some platform SDK you need to be able to run code on a particular platform, like the Windows SDK, for example. Debuggers. If you're a game developer, maybe you'll have 3D models and sound files and other stuff that you might use that are part of your project. They're not directly related to C++, but they're still part of your project. But in general, there is a generic packaging support. So you can produce a package with a lot of different things in it. It doesn't have to be just code that you compile. So you can still work around that. But if you check the catalog specifically, you're probably not going to find all the tools that you might want available that way. And the other big thing with C++ package managers is they work across multiple platforms, architectures, and compilers. Because they're focused on C++, they understand that C++ has a very diverse community of tool vendors and a lot of people using the different tools, and they try to support at least the popular ones. All right, so then we have the non-C++ package managers. So the only one that really shows up on that survey, like that's actually a big one, is NuGet. But I listed the other ones because some other ones, I mean, there are actually many other more that you could use. But these are basically package managers that you normally think, okay, if I'm doing Python, I'm going to use pip. If I'm doing Rust, I'm going to use cargo. If I'm doing Node, I'm going to use like npm. If I'm using C#, I'm going to use NuGet. But there may be cases where you have a project that might be primarily in that language, but has some C++ components that it need to be pulled in. There are definitely C++ libraries that are being produced and then consumed for use in other programming language workflows. And in that case, yeah, you might find packages. If you go in that package manager, you might find packages that are C++ related. In general, I'm not a huge fan of using other like non-C++ package managers for C++ development. But if you have like a more simple scenario like I outlined, then maybe it's easier so you don't have to add another package manager to your list. But again, we have certain problems that are C++, that are more common in C++, like having to build from source and dealing with the diamond problems and all that. And I do think there is value in having C++ package managers for dealing with that. So just to drill in a little bit on NuGet, because it's 9% of the survey, and I think it's been fairly consistent. I often get feedback about, hey, when are you going to improve the NuGet story? Since we also work on NuGet at Microsoft. When are you going to improve the NuGet C++ story? And the answer is, well, it's just not a priority for us right now, because the way we see it, it's not really designed for C++ development. It doesn't cover these core scenarios that we think are important for C++. And that's why, in part, we started working on Vcpkg. It doesn't mean that you should never use NuGet for C++. It just means that you have to understand there are going to be some limitations. And one thing I found with package managers and probably all software is it's good to be specialized to certain tasks. Like have a target market, have a certain focus. Like, what are you trying to actually accomplish? Don't try to do everything. If you try to solve all problems for all users, you're probably going to fail spectacularly. And I've often been asked in the past about, can you make a universal package manager that just, it's the one package manager to rule them all? And I don't see that as being very realistic at this point. I can't even imagine what it would look like. It would probably be very complex. But instead, what you want to do is pick the right package manager for the job. So when should you use a particular package manager? Well, like I said, if you're like targeting one system, maybe system package manager, especially if you're not often creating these ABI breaking situations, and you're not too picky about libraries, versions, or you don't have too many dependencies and you're not running into these problems too much, that could work out for you. If you're using primarily another programming language, you might need a strong reason before you add another package manager to the mix. And if you're, there are certain packages that you're more likely to find in a system package manager than a language package manager. If you're just looking for, oh, I want to find a variety of C++ libraries, well, you probably want to look at a C++ package manager. But if you want to find, give me like this Linux-only graphics library that video game developers like to use that works on this Linux distro, well, that might be a better thing for a system package manager. And then, yeah, and broadly speaking, if you don't, if you're not using anything and you're not sure what to use, I would say a reasonable default is a C++ package manager. And again, Vcpkg and Conan are the two big ones. They're actively maintained, they're open source. They're getting a lot of contributions, but there are other options you could go look online for. There are many options out there. I'm just saying those are the two big ones that have been growing in the survey. So that's where it seems like the market is going. All right, so reproducible development environments. So apparently there's a whole talk on this, so I'm not going to talk too much about it here. But one issue that I've started caring a lot about recently, working on Vcpkg, is how do you actually get everything on your machine before you can even start worrying about how to build your libraries in your project. And that's when we have to worry about things like, okay, how do I get my compiler? How do I, like if you're on Windows, how do I get Windows SDK? All of that is like many gigabytes right now. And it's, the way you install it is a bit complicated, and you need elevation, you need to run an MSI to get the Windows SDK. There's all these steps, and people are not very happy about it, especially if you're trying to install it in CI. And so I've been looking at, okay, how do we actually make this better? Maybe by having a good package management experience for it. And certainly system package managers have been used for a long time, especially on Linux. For like you want to get GCC, well, you know what command to run in apt, for example. It's pretty straightforward. So we're working on doing something similar with Vcpkg on Windows, macOS, and Linux, I guess, but it's going to be mostly interesting on Windows since we don't have a very good story there right now. It's my belief that in order to have a really complete C++ package management experience, you need to be able to get your dev tools and then use those tools to build your libraries and then be able to build your project itself, ideally in one step. And the way we've been doing this at Microsoft is basically, there's this tool that we've been using that basically has 3 steps. There's clone, init, and build. And essentially the clone is what it sounds like. You're cloning your repo. Init kind of sets up your environment, and then build runs the build. But it turns out because it's like an internal only system and there aren't many people maintaining it, and it's kind of getting dropped. And we're looking at like building a more public solution for that. And we've been doing that, and that's basically what we're working on with Vcpkg artifacts. Conan, I believe, also has support for getting dev tools as well. And this is an area that I think needs more investment from the package managers. But I think a good future will be one where everything is a package, even if it's your compiler. And you have some way of declaring in your project in some file, like a manifest that goes into your project and it goes into your repo that says, give me these packages, these versions, these specific conditions that I want for how I get this. Like these are the optional features I want. Being able to declare everything. It takes a while to build the file, but then once you have it, anytime somebody new joins your team, they clone the project, and they should be able to go try to hit build, and then it should be able to call the package manager, get everything you need, and then the build system can go and do its thing and build your code. That's kind of the future I'm hoping for. So you can achieve this partially with the major C++ package managers today, but you do need to do some work to kind of fill in the gaps. All right. Kind of in summary, some of the principles to keep in mind for managing dependencies well. Building from source, I think, is very, very important, or having the support for that. Doesn't mean you're building from source every single time you're restoring a dependency. That would be ridiculous. But you should be able to do that so you can customize your experience. And then you need to have a way of being able to get the pre-built assets once they've been validated that they're actually good. So if you build from source, have them cached somewhere, or even just download a pre-built one if it's available online that happens to match what you want. And the package manager should do some level of validation for making sure you're not downloading the wrong thing and wasting your time. You should also keep your dependencies up to date as much as possible. Security vulnerabilities are a big reason, but even without security vulnerabilities, there may be runtime performance boosts that you get from getting a newer version of a library, for example. There may be new features you can take advantage of. So it's very useful to be able to do that and have a good iteration in terms of how fast you're doing that. I also think about cross-platform development, even if you're not currently targeting more than one platform. Another thing I've seen in surveys recently is there's been more and more focus on targeting more and more platforms. CMake usage has risen a lot. I think it was like 81% in this year's survey. Think about how to make your code cross-platform or make it friendly towards being migrated to cross-platform in the future. And that's something C++ package managers can help with because they're already designed to handle many different platforms. Make your build environment reproducible. Some package managers might be able to help you with a little bit of that. Build system helps you with a bit of that, but you might have to add some more scripting yourself potentially to get that 100%. And then also take into consideration what is the workflow for actually producing packages and making them available for others to use. Because if it's a really bad experience, then it's not going to incentivize creating a large catalog because nobody's going to want to create packages for that. So the major package managers, I think, have been working on the story for that and having a workflow that makes sense and is reasonable and doesn't take too much time to be able to produce your own packages, whether they're on private ones or if you want to contribute to an open source one. And yeah, take advantage of open source projects that are out there. So the big package managers are open source. There's lots of open source libraries that you can download as packages. Take advantage of them. Don't try to do everything yourself. It will probably take a lot longer. The maintenance cost will probably be a lot higher because you're essentially maintaining a lot more code. And it's easier to run your package managers and just have it update the library than you having to actually write that code yourself and do that. And the other thing to consider is for ABI purposes. You want to make sure that you're building everything consistently. Don't treat each component of your project, each package effectively, in isolation. There are different ways of doing this. So again, as an example for Vcpkg, what we have is, we have this integration with major build systems. So like for example, for CMake, when you run CMake to generate your cache to prepare yourself for a build, CMake will have certain information about like, okay, you want to build for x64 Linux, and here's exactly how you want to build it. Vcpkg has a CMake toolchain file that it provides that if you add that to your CMake project, it'll know to basically call Vcpkg, and then Vcpkg will be able to infer, okay, it looks like this is how you want to build your package. So I'll make sure when I get all your libraries that I build them the same way. And as a user, all you're doing is the usual step. You're running CMake and then you're running your actual build. So you're not really doing any extra work, but behind the scenes, it's all automated and it's figuring out, your build system and your package manager are talking to each other, figuring out what to actually do. And we have something similar as well for MS Build, where like when you try to hit build on MS Build, it does the same thing. It runs in the background and it reads what you want. And in general, the main scripting you have to do to set this up is to write a manifest file that says, here's my list of dependencies. Maybe here's my list of versions or optional features, whatever. Whether you're using Vcpkg or Conan, you'll see that that's basically the workflow. And the last thing I wanted to say was, it's okay to use more than one package manager. I get a lot of feedback from people about, can you just consolidate, stop creating package managers, just make one? I think it's much harder to try to make one package manager than it is to use like 2 or 3 package managers that are specialized to their particular needs. You might be pulling one package from the system package manager, and you might be pulling several packages from your C++ package manager, but it's worth it because sometimes it's just the best option for the job. Sometimes the system package manager has the thing you need in its catalog, but the language package manager doesn't, or the other way around. Sometimes you have a package that you really need to worry about the ABI issues and the daemon problems. So you want to make sure you handle it with a package manager that can handle that experience really well. It does take time. Every time you add a new package manager, you're modifying your build workflow. But the real question is, what is your ongoing maintenance cost going to be? If it's probably going to be lower, then that's an argument for adding that automation in. All right, and then I want to say C++ package managers should be accessible and productive for all C++ developers. So this is what I think of. Like if I think of what does a C++ package manager need to accomplish, it's this. By accessible, I mean consider the fact that C++ developers have many, many different types of workflows. We don't have a single build system that everyone uses. We have many. We don't have a single compiler that everyone uses. We have many. We have many different architectures that are being targeted. We have a very large number of potential libraries that could be added to be usable with a package manager. You want to have good breadth, like cover as much of the space as possible, because that's going to ultimately determine how many users you get. And I think part of the reason we're seeing some consolidation out towards these two package managers, Vcpkg and Conan, is because these tools are getting the most investment in this, and they've been growing and expanding their scope over the years. And you're more likely to find what you need by using one of these two than using a package manager that might only be maintained by 2 people, let's say. So we may see some consolidation in the future for that, but in general, it's very important to be as accessible as possible. And you want the users of the package manager to be more productive after they started using the package manager than they were before. If you're taking longer to figure out how to build your code, or if you're still very hesitant about updating your libraries, then maybe something's wrong. And then maybe that workflow with the package manager is just not working. The other thing is consider contributing to an open source package manager. So I know there are lots of people that work at companies that have what they call in-house package management solutions. I talked to one recently that apparently had one that's like decades old. And that's the thing they've been using for managing their C++ packages. That's just how their workflow works. Now that can be fine if you're a larger company and you can put enough people to really work on that and maintain that. But it's going to be a lot of work for a relatively small number of people compared to using an open source project that has a lot more contributors, people adding to the catalog and people adding to the tool itself. So in general, if you're going to use that time, you might as well use it contributing to an open source solution and making that better for everyone, including yourself, rather than just trying to maintain yet another in-house solution. At Microsoft, we have a company-wide effort to get all our developers using publicly available developer tools. We've built lots and lots of in-house solutions. Many different teams, from Office to Windows to the developer division itself that makes Visual Studio, have been coming up with their own ways of doing software development. But what we found is that it's actually better to go for something that's public, that's getting a lot of feedback, that maybe ideally if it's open source, even better, because then it's like it's as if you're collaborating with a much larger group of people rather than just within your own organization. And I think in the long run, you will end up being more productive and getting great features available to developers more quickly by taking advantage of open source and contributing back to it. Okay, I think I have 12 minutes left. So just quickly, this is a list of some Microsoft sessions at CppCon. Please feel free to check them out if you have the time. There's a number of tooling related ones from the reproducible development environments, embedded tools, Visual Studio and Visual Studio Code have talks as well. And there's a bunch of other ones. There's also Herb Sutter's keynote, I think that closes the conference, I believe, on C++ complexity. So feel free to check those out if you'd like. And lastly, I would like to, I'm always interested in hearing feedback from people about how are you managing dependencies? Like what does your workflow look like? Is it working for you? Are you running into problems? It's always great to have these kinds of conversations, especially at an event like CppCon. So if you're interested, find me later and I would love to chat with you about it. Okay, and this is just a repeat of the slide before. Again, if you want to follow up afterwards, there's the Visual Studio channel on the CppCon Discord, or you can swing by the Microsoft booth if you're here in person, which is, we're here today and tomorrow. Okay, and that's all I had for my presentation, but actually, I'll just quickly do one, for 1 minute, I'll just show something else, just to give an example. So this is an example of a project I have in Visual Studio. This is an open source project I downloaded from GitHub. It's a video game. It's fairly large. It takes a long time to build. And it's actually set up with Vcpkg. And this is an example of a Vcpkg manifest file. This is vcpkg.json. And it's installing SDL2, and there's a bunch of like optional features that are specifically being set. It actually takes quite a while to build all of this from nothing, and then build, of course, the project itself. But the interesting thing is, I spent a grand total of about 5 minutes actually figuring out how to build this thing, and having no experience with it previously at all. And I'll just prove that I built it before, because I'm not going to do it in real time now, but see it's up to date. And just to prove that it runs. Yeah, so I spent about 5 minutes actually doing this, because all I had to do was I went to the GitHub repo, I cloned it, I looked at the instructions. It basically just said, oh, here's where you can find the file so you can open this in Visual Studio, and here's how, and then basically just make sure you maybe build it for release instead of for debug, because it takes longer on debug. And then basically that's it. And all I had to do was go and hit build. I didn't have to think about exactly what dependencies does this project have? How do I build those dependencies? Are there any daemon problems I have to worry about? Am I actually building this the same way that this project is supposed to be built? Because this manifest basically just tells Vcpkg what to do. And Vcpkg is hooked into the MS-build build system that's being used here. And all it's doing is, when you try to hit build, MS-build has a step early on, because one of its properties says, oh, you're using Vcpkg. Okay, let's see what Vcpkg wants to do. And then Vcpkg finds the manifest, gets the dependencies, and then the rest of the build happens. So as a developer, all you did was hit build. You cloned, and then you hit build. Nothing else happened. So that's the kind of workflow you can have with a package manager. Okay. All right, if there are any questions, I would love to take them now.
I have a question from online. It says, for what it's worth, we are using Conan and Docker to build. We tied our Conan profile name to the Docker image name, so we don't have to manage the compile build environments with Conan. I guess I wanted to point out that that's an option to a problem that you stated and that hasn't been solved. I don't know if that, that's what it says.
Yeah, so there are some problems that package managers do solve, and there are some problems that are yet to be solved. The general point I'm trying to make is that you are likely to be more productive by taking advantage of the automation you get from a package manager, because you don't have to do that work yourself manually. There may still be work you have to do manually, but that's still less work than you'd have had to do otherwise, and these package managers are evolving. So like Vcpkg and Conan are both like actively being developed. There's a lot of interest in these projects, and even the problems that exist today, maybe they're not a problem in a year from now or 2 years from now. That could change. Like I mentioned, reproducible development environments, that's something we're looking at with Vcpkg, for example.
Yep. You doing anything to manage licensing compatibility with all the various components of the build system that you're pulling in, especially if you start mixing proprietary and open source libraries?
Yeah, so for Vcpkg specifically, I don't know exactly how Conan handles this, but for Vcpkg, we kind of avoid the whole licensing thing because we have build from source as the default. We don't provide pre-built binaries of anything. So essentially it's the user opting in to say, okay, I'm downloading this thing and I'm building it. And it's essentially up to the user to say, okay, I'm accepting the terms of whatever I'm choosing to build. With pre-built binaries, it does get a bit more complex. You have to think of things like EULA acceptance. When I was talking about the reproducible development environments, and we're now thinking of doing things like making the MSVC tool set available with Vcpkg, which definitely has a EULA, and you need to satisfy the EULA. So now we're looking at actually adding additional functionality to it to actually support having some kind of EULA acceptance or some way of having the user understand that there's a license for a particular package and agreeing to it, that they're satisfying it.
First of all, thanks for the talk. Very interesting topic. Like one thing that struck my mind, I mean, you said that like one reason for having multiple package managers is that like, yeah, so maybe with one package is available in this one and one package is available in that one. Kind of that sounded a bit circular to me, because if you didn't have multiple package managers, then naturally everything would be available in one. And I kind of like, to me, it seems like comparing my experience to like programming languages that have one strong choice, like Cargo for Rust, for example. Like I'm like thinking about, would it be somehow possible to at least have the same user experience in C++, for example, by having a common format or a common standard for how to represent a package, such that it would still be possible to innovate different ways by having different package managers, but still also not having this kind of fragmentation, which might be a problem for users.
Yeah, that's a great question. So I guess if I'm understanding correctly, what you're asking is, so the market is very fragmented. There are lots of different ways out there right now for managing packages. And there are other languages that don't have this problem. And is there a way we can, I guess, consolidate and end up like those other languages? I think we have a couple of challenges with C++. One of them is that C++, having been around for so long without any mandated tooling by default as part of the standard, it resulted in lots of different people making lots of different tools, often just for their own team to use, that maybe ended up on open source as well. But you ended up with like a very fragmented market. So if you're not designing with this goal in mind from the beginning of the existence of a programming language, it's very hard afterwards to put the genie back in the bottle. And what we have right now is a number of different package managers, from system package managers to language package managers. And they do tend to have different areas of focus. So if I'm telling you what to do today, all I can say is, well, yeah, some things you might find in your Linux system package manager, some things you might find in a C++ package manager. That's just the state of the world. Like if you need to get this package today, that's what you probably have to do. Could that happen? Could that change in the future? Yeah, I think it could. I think we're seeing, like if you look at the package catalogs, for example, for Vcpkg and Conan, they've been growing very, very fast over the years. Like Vcpkg has only been around since 2016, and we have over 1,900 libraries right now, and now we're looking at non-library dependencies as well. So it's possible, but it might take a while, and in the meantime, this is just where we are. And the other, I'm trying to remember what the other point was. I think there was a second part to your question that I forgot. Package standards, yes. So the other part of your question was, can we have like a standard package format? I would kind of like that. There are certain things that bug me as somebody who works on a package manager. Like for example, there are, out of the 1,900 plus libraries we have in Vcpkg, even the way versioning is done for them, there's no agreement there. Some of them are using semver, which in my opinion is the gold standard for versioning. Some of them are using dates. Some of them have like a weird combination of numbers and letters. Some of them have clearly incremental numbers, but there's no distinction between like a major version or a minor version. So it's like every version is treated as the same every time you increment, whether it's a bug fix or a really big update. And I think that's a bit unfortunate. And there are some other areas in terms of like, some library might build specifically with a build system that most people are not using, and you have to figure out how to compile with that. Like with Vcpkg, we had to come up with all these different unique build recipes for special libraries that have special requirements. So it would be great if we had some consolidation there. I think we would need to have an agreement on a build system before we can really have agreement on a package format. But there are certain like metadata parts that would be nice to consolidate, like the versioning.
I have another online question. Actually, I'm going to do two right now. How do package managers handle different build systems and generators like CMake, Premake, QMake, etc.? And then tying on, regarding keep your dependencies up to date, how can you trust open source projects? Is the guidance always to use the latest of everything?
Okay, so for the first one, how to handle different build systems. So I've seen two schools of thought, I guess, with package managers. The one Vcpkg uses is basically we try not to change our build system at all, and we just integrate with it as best as possible. So for example, if you do CMake find package, it should be able to find Vcpkg packages without you having to write any special scripting for it. Some other package managers may choose to be more prescriptive and say, okay, well, we don't like the way build systems work right now for C++, so we'll kind of create our own build system-like thing and have its own way of managing packages that's really well tailored for that. And the experience should be really smooth for that, but that means you're adopting essentially a completely different workflow, not just in terms of how you're getting your packages, but even how you do your builds. So those are the two directions I've seen. Personally, I prefer not modifying things as much as possible because it's already enough work adopting a package manager in the first place. And sorry, what was the other question?
Sorry. It says, regarding keep your dependencies up to date, how can you trust open source projects? Is the guidance always to use the latest of everything?
So you can't just blindly trust open source projects. One thing that we're doing at Microsoft, for example, is we actually have been working on a mirror of the Vcpkg public catalog, and it's basically just like it's just a copy of it, but it goes through additional validations that the company wants for security and compliance purposes. So if you want to run like certain tests on the open source code, like if you want to run address sanitizer or something, you could do that and add it to your workflow, and then just have your developers pull from that private feed rather than a public one. And that's basically how you overcome the trust thing. Because yeah, Vcpkg does have its own logic that it runs to validate packages, but you may have your own unique requirements, and you want to make sure that those happen your way. And so there's a way to do that. Okay, and I think we're out of time, so I'll go now. Thanks, everyone.